Pythagorean theorem, let's start with the basics and the parts of the triangle. Looking at this first part, the A and the B side are the two sides that form that 90-degree angle, and those are called the legs. The A and the B side are interchangeable, meaning if you said the B side was the A side and I said the A side was the B side, they are interchangeable. So you can call this A or B, you can call this A or B. They are interchangeable. The C side is the part that is directly across from the 90 degrees. This C side is called the hypotenuse. Please make sure that you're filling in your notes as I'm filling this in up here. Hypotenuse, let me write that on the board because it's not showing up very neat. So the hypotenuse is special because it is directly across from the 90-degree angle, and there's only one side that can be called the hypotenuse. It's important that you see where that is. Now, this picture is drawn very nice and neat. It's probably easy to pick out that C. Keep in mind that it could be twisted and in different locations when you're given different kinds of problems. So you still have to be able to identify where C is. Pythagorean theorem is used to find the missing side length on a right triangle. It will only work on a right triangle. So if it's not a right triangle, you cannot use the Pythagorean theorem. My formula for the Pythagorean theorem is a squared plus b squared equals c squared. You do need to memorize that, and we're going to keep rewriting it until it gets stuck in your brain and you're able to apply it. So the first thing we're going to do is prove that these figures are a right triangle. Just put it on my desk, please. So far, you need to be able to label the A and the B, which are our legs, and label the C, which is the hypotenuse, and know that it works only for a right triangle, and the formula is a squared plus b squared equals c squared. The next section. So this section says prove if it's a right triangle. I said a minute ago that it will only work if it's a right triangle. These three numbers that are given to us, we need to figure out if those three numbers can form a right triangle. So we need to know if a side of 8, a side of 15, and a side of 17 will form a right triangle. So what we're going to do is use the Pythagorean theorem and see if it works. So do this with me. Make sure you're doing everything the way I'm doing it. I'm going to label this as A, B, and C. C will always be your longest side, and typically it's given to you in numerical order where the A and the B is first and the C is last. I'm going to write my formula. A squared plus b squared equals c squared. Always start by writing your formula. You're new to it, and the more that you write it, the more you're going to get comfortable with it. The next thing I'm going to do is plug in my numbers. I've already identified that A is 8, B is 15, and C is 17. So I'm going to take out my variables and plug in my numbers. So instead of a squared, I'm going to write 8 squared. Instead of b squared, I'm going to write 15 squared. That's really sloppy. Let me try that again. Bring down your equals, and C is 17. So with our equation solving, remember, you're going to do something and keep bringing things down, just like we did with our equations. So now our goal is to figure out if both sides are equal. If they are, then we'll have a right triangle. If they are not, then it's not a right triangle. So the first thing we're going to do is get rid of those squares. This is what you practiced before you even came into class today. So let's simplify. What's 8 squared? 64. Who said 16?
Zach.
So what did you do wrong?
I did 8 times 2.
And what should you have done?
8 times 8.
Okay, good. You know it. I need 15 squared. What's 15 squared? Who's got Desmos open? What's 15 squared?
225.
Thank you. And I need 17 squared. What does that give me? Go ahead.
289.
Thank you. So remember, my goal is to figure out if it works. If it works, both sides are going to equal the same number. So on this side, 64 plus 225, what does that give me? Either on Desmos or in your head. What happens when I add those two numbers?
Equals 289.
So when I add these two, I get 289. Notice I'm bringing everything down with me. This is an equal sign. So because it works, meaning both sides have the same number, that means my answer is yes, these three lengths can form a right triangle. Because the Pythagorean theorem works, meaning both sides are equal. Let's look at number 2. So same idea, we're going to figure out if these three side lengths can form a right triangle. So I'm going to start by labeling A, B, and C. Remember, C is always your biggest side. We're going to write the Pythagorean theorem, A squared plus B squared equals C squared. My next step is to substitute. Take out A and plug in 5. Take out B and plug in 9. And take out C and plug in 12. Let's get rid of those exponents. What's 5 squared?
25.
Good. Bring down the plus. What's 9 squared?
81.
Good job. And 12 squared?
144.
Good job. 144. That's kind of sloppy. On the left, let's add 25 and 81. What do we get?
106.
106.
So the left side is 106. The right side is 144. That is not equal. This is not a right triangle because the Pythagorean theorem does not work. This is what I'm talking about when I say it does not work. It means that when I plug in the A and the B, we square it and add it together, it is not equal to the C side. So this is not a right triangle. Do you see the difference between when it is and when it isn't? Does that make sense? Okay, go ahead and do 3 and 4 for me.